Well, welcome to our December additional structural integration modeling uh, video conference. Kevin Dye is going to be presenting some aspects of a problem that Peter Pudenham asked him to look at. So that's about as much as I know. So I'm going to turn it over to Kevin.
Okay, thanks, Joe. I'm going to switch to screen share now. Do I have control?
You should. Let's see here. Let me. Yeah, you have. Okay, you should have control of the screen. Okay, so this is being a little.
Do you see my screen?
I see your screen. I have a.
Whoops, I did for a minute, then it disappeared.
Oh, it can do that if it's voice activated control. I think that's a setting or.
Yeah, so what I seem to have. Okay, here we go. I'm in a little better shape now. Got a. Seems like a mode lock has happened on this interface. I'm going to try to. Here we go. I'm out of that. You should have control of it. Do you see that now, Kevin?
It says you are screen sharing. Is it supposed to say something else?
Okay, so yeah, I just saw your screen on my screen, and you should have the voice activation as well.
Okay, let me try again.
Okay. I see your screen.
You see it? Okay, Peter, do you see it? Are we set now?
I see it when you're talking, and of course, now I'm seeing myself on your screen, so you need to minimize that.
Okay, so you have to mute your speaker. And Joe, if you could mute, and then I won't talk too long before I invite conversation.
Yeah, but you need to minimize the Google screen because it's covering up your screen, okay?
Yeah, I'm just trying to get you on here. So,
we can see your screen, but if you're talking, I can't hear you now.
No, I'm not. I'm looking for. Okay, so in terms of the basic structural modeling project, we've talked in the past about moving towards comparing.
You went away, Kevin. I can't see your screen now.
You have any suggestions? Maybe we should try handing control over again, or.
Well, we saw a screen when you had the concept map up there, and then you were looking for something else, and it went away.
There it is.
Okay. So I decided to take a toy problem, which is a small slice of something that Peter showed me, and show you how one system for doing interpretive structural modeling works, and get an idea for how you might work as a group online. In Peter's project, he's talking about having multiple people that are in different places talk about how teaching certain systems concepts may help people learn certain concepts in ocean science. So that's what I have here. This is principle 1. I think there's 8 or 9 principles. And I'm highlighting this slice over here of concept 1 through concept 6. And I entered the text of these statements in the Cognoscope software. And then I answered the questions about whether there was directed linkages between these items. And I also added a small selection of systems concepts. And so that's what we're going to add into this structure. And we can go along here. We're not experts in ocean science, and so we may not have that interesting a discussion, but you can get a sense of at least how the system would work. So I'm adding in the first systems concept, and we're not interested in whether learning an ocean concept helps teach a systems concept. It might, but what I noticed about this structure is that they presented is it's like an outline. There's not too much crossover between major groups of concepts. There's no cycles. And so I'm going to kind of stay with that style. And so when we have an ocean concept influencing a systems concept, I'm going to say no for now. So this is the type of question that Peter told me they want to be talking about. So suppose we're able to learn about or have some piece of curriculum or learn about the systems concept of boundary. Would that help people learn concept C.2 about wind-driven currents? We should unmute so we can have a brief discussion.
Okay. Well, I know, so from what I can tell is just my impression about what's going on here is wind-driven currents are directed in what GYR, whatever that is, by the Coriolis effect, right?
Ajaya.
Ajaya, okay. So the Coriolis effect is basically physics based on physics, right? So, and the currents are directed because of the physics of the fluid dynamics and so forth. So there's a lot of boundary conditions and ideas throughout, you know, fluid dynamics and physics. But I think it's more of an idea of what is the level of the boundary. But I'm having a hard time kind of figuring out, you know, what the space is here. So that's my comment.
Yeah, I don't see a strong relationship on this one myself.
No, I was wondering, you know, you've got to do a yes or a no. I mean, can you not have a maybe?
No, not in this system.
No, you can't. No.
There are there are implementations of ISM in Japan, for example. They call it flexible ISM and fuzzy ISM and gray ISM, and they work with gradations. But the way you keep track of that, when you are just getting a group to say yes or no, is to keep track of the votes. How many people say yes? How many people say no?
Okay.
And that it gets layered onto the structure later. But that's a manual thing if you want to keep track of it. There's people that argue that the point of pressing people to say yes and no incrementally is to have the deliberation drive consensus. Because if and another opinion is that unless almost everybody agrees, you don't want to say yes because it indicates uncertainty. And what we're trying to map is, generally what we're trying to map is things that are highly certain. So in terms of this structure, a curriculum structure, and you're going to have a bunch of educators and system scientists and ocean experts talking, that when they come up with a line connecting two things on this structure, you want to know with confidence that almost everybody agrees about it. If we say maybe, then what does the structure mean? It means that maybe it might work.
Can you hear me? Actually, I just joined on my iPad and I'm not sure if I'm coming through.
Yes.
We're traveling, so I'm not sure if we can stay the whole time, which is my first question is, are you taping this?
Yes.
Okay, good. The second question is, what does implement mean here? We just came in late.
If they implemented a curriculum around the boundary concept in systems.
Yeah, that to me, that gets at Joe's point about what, that there's so much variation possible between implementing a curriculum and the physics of the gyres and the Coriolis effect.
No, it's not implementing the physics. It's implementing
what I'm saying is implementing a curriculum to me is it's a very vague, what does that mean? If
no, it's just implementing like a lecture around the concept of a boundary.
I understand, but how can anybody judge what that means, given how, they could implement the curriculum, but do the students, as Sue Gabriel would say, do the students pick it up? If you phrased it as, would having the students pick up the concept of boundary help them grasp, X? So help them grasp the concept of wind-driven currents. It just would operationalize it a little more at something where maybe you could answer that question.
Yeah, a previous version that I had with the question was, if we help people learn about the concept of boundaries, would it help people learn about the concept of wind-driven currents?
Mm-hmm. Right. I do think that's more operational. I think that Sue's language of pickup, I don't know if you're familiar with that, but she has, after over the course of all of her years of work, she has come to the conclusion that the teacher can set the stage for pickup. The student has to respond with some aha, where they actually are, physically and mentally grasping something. That gets you into a state of, well, you're able to talk about events. Then you can talk about, would this event, this pickup event, influence this other pickup event? Just, it's more along the lines of what you said your first version was, because implementing curriculum can be a bureaucratic accomplishment, but who cares, right? It's so it just sharpens your the focus. There still would be questions about would grasping or picking up the concept of boundary help with this other concept that you want them to grasp? But that people could debate that, but at least their attention would be narrowed on the relationships between the concepts rather than the relationships between the curriculum modules, curriculum modules. So that's my.
I think it's a good point.
I think that the yes no, you know, you want a nice clean model, as you said. You want an interesting structure that to some extent is speculative. You're saying, what if it's the case that this influences that, and you don't really want to assess the vagueness of everything so much as say, what if it were the case that all of these things had this kind of structure? Then when people discuss it, then they say, but I don't think that would really be the case, or then they can go back and change it. But you want a clear yes no type model so that people have something to sink their teeth into. Otherwise, it's again, there's too much ambiguity for to really evoke any kind of insights. So I think the fact that it's binary is not a problem. I think it's actually a benefit. And the questions of how you treat that is where you get at what Peter's concerned about. I think it being too rigid and constraining, but you want the constraints and the rigidity in the speculative model, and then people can use their judgment on top of the model.
Yeah. Typically, we keep track of how many people say yes and how many people say no. And that's a measure of fuzziness at the group level.
Right.
And at a later time, and it depends on what voting rule you have. A lot of work is done with a 3/4 majority voting rule to get a yes. And what you can do is, if you have the voting record, you can later relax what the relax the rule, maybe just make it 51%, and see what the structure looks like. You end up with a lot more links, of course. Everything, everything starts to look like it's related to everything when you relax the voting rule.
Right, that's a good point. So the variety is in your you can have multiple models, but you don't have the vagueness within the model. You have the variety by having multiple models that each provide a different picture.
Yeah. And you could, well, anyway. Okay, so let's go through a few of these. I have to go in 10, 15 minutes. I'm going to say no for now. We didn't take a vote in the group yet, but let's take a vote. Mine's a no. Joe sounded like you were saying no.
Yeah, no, definitely no.
Peter, do you have an opinion? You're the one that's more expert on this.
Well, I don't know that I wouldn't never claim to be an ocean scientist, but I would say yes.
Okay. And Janet?
I would say yes.
So we have it an even split, which is not 3/4 majority, so it's a no. So how do we want to word this now? Suppose a student learned about the concept of a boundary from system science. Would that help them learn about the concept C.5, the upswelling from ocean science?
Yes.
Yeah, I guess the thing that I'm struggling with kind of at a fundamental level is the Coriolis cause upswelling in winds and so forth. I really don't think that you can grasp those concepts at that level without understanding boundary. I think, does that make sense? I mean, Coriolis effect, where you understand what a Coriolis effect is, you have to understand the concept of boundary.
Right. What? Yeah. Maybe does the influence go at least as much in the other direction?
Oh yeah, of course. I think of course it does. But I mean, this is the interesting thing that starts to actually come up immediately when you ask the question, doesn't it? Because there may not be a clear understanding of the concept of boundary with someone looking at upwelling due to the Coriolis effect.
Are you interested in the influences in that direction from, using concepts in ocean science to learn about concepts in system science?
Oh, absolutely. I think there's there's no reason why not as a project. And indeed, it's one of the things that Janet and I and many others have talked about for a long time here, is that the project of systems literacy that we have defined is an evolution of the work that we've done on ocean literacy and other geosciences, at least it is for me, and that the interrelationship could be very illuminative or illuminating in both ways. Absolutely.
Okay. I would tend to say yes on this direction. So,
yeah, I would.
So is that a yes from everyone? Peter?
Yes. Mm-hmm.
Yep, sounds good.
Okay,
yes. Yeah. But I
yes.
do think, I think seeing it in both directions.
Yeah, well, the other direction would come up later.
Right.
And there is software that allows you to ask both, if it's one way, the other way, or both ways. It's not this package. Other packages, you answer it all at the same time. So let's
Yes.
ask this one.
Oh, well, so this does go in the other direction. Interesting.
Right. See the wind hits the surface of the ocean, so I guess that's a boundary condition.
Yeah, and of course, wind, ocean currents stratify due to temperature differentials, which create boundaries. So, yeah.
Any no's?
No, yeah, yes.
Okay, we're going to say yes. So another way to take the votes, if you have a large group, is to use the chat box, and everybody enters their vote yes or no as they go, and that creates a record. But in a small group, we're just chatting to get an idea of how this works. So suppose someone learned about the concept of boundary. Would it help them learn about concept C.3, surface currents?
Yes.
And subsurface and surface currents. Yeah, I think so, because there's a boundary between surface and subsurface of sorts, I guess.
Can I ask, what is the triggering question?
The triggering question is what concepts help people learn about ocean science?
Right.
We created you missed the beginning.
Mm-hmm.
We're talking about this chart here on the left, which is about concepts, and we're just looking at concept C1 through C6 in this overall. I don't know if it's Peter. Are you referring to this as a concept map or a curriculum structure?
Well, it's actually it's been referred to as a learning progression, interestingly, but it is what you are looking at has been created in CMAPS from the folks in, as a piece of software. So it is created using a concept mapping software, but the term that has been applied to this is a learning progression.
Okay.
So does that suggest that one of the things that is of interest is determining the ladder of concept development of?
Yeah, you could do that if you're an ocean scientist, and we were looking at it. I think what Kevin has been picking up and is demonstrating, I mean, is a discussion we had a little earlier on where last week or a couple of weeks ago about the relationship between ocean literacy and systems literacy, and using that as an illustrative way to use software and the ISM in a distributed mode, Janet. And that's what I've been looking at, is how would we, I mean, we could just do it within the concepts of systems literacy. We could break them out and start saying, how do they relate and how do they order themselves? That would be a fantastic exercise to do under even the concept of boundary. I mean, we've already started discussing aspects of boundary in relation to those ocean concepts or ocean science concept, whatever. And I think, even just having this discussion has helped me even think about the notion of boundary in a systems, in the systems arena, or systems field.
So the ocean science concepts are they exist in some curriculum and are used with this structure?
Yes.
Okay. So this is about trying to see the interrelationship with some systems concepts.
Correct. Exactly.
Yeah, very interesting. So the fact that they complement one another is definitely that as you learn one, you can understand the other better in both directions is not surprising.
Exactly. I mean, in a sense, we're exploring the relation of the cross-cutting concepts, if you like, to a particular science and the mutuality of the relation, right, and helping to actually understand both, which is already quite fascinating as a process for me that Kevin has initiated here.
That's right. I think what he's brought out here, and it hadn't really sunk into me, is the being able to see the complementarity, that how key that is, that one goes back and forth rather than assuming that one is foundational to the other. Yeah, go on, Kevin.
I just note that in the ocean literacy concept map, there's no cycles. So it's a little suspect to me. I'm curious why that is. We're talking about how systems concepts would influence ocean concepts and vice versa, but there's no examples in this map, in the ocean literacy map, where two concepts are in cycle with each other.
Mhm.
And I just thought that was kind of strange.
Well,
Yeah,
I think it's more than strange. I think it's an incredible insight, to be honest.
Yes, yes, very important. Huh.
So I have to go in a few minutes. So I just want to just go through yes and no's these so to show you what happens. So I'm just going to say no for the rest of them for now because we didn't have a chance to ask them. I'm going to end the process. And so this is the structure. You see that the boundary concept is there in the center of the structure. The rest of the relationship of the ocean concepts to each other is still preserved. Those haven't changed, but it fitted in where the boundary concept would go based on the few answers we gave it.
Very interesting.
Mhm.
So I have to leave now. I feel bad about that. I didn't know about this engagement that's happening around the corner from me here. So I'm going to leave you to the discussion. So you want to switch back the screen now.
Thanks for your presentation, Kevin. It's very interesting. Hopefully we can continue it in the next meeting.
Yeah, what I'd like to do is go use the same 6 concepts and the structure there as a toy problem and put it in your software. And then we can have, because we want to do larger comparisons as a test bed between systems. It's something that we've talked about for a long time. So I just took the opportunity with Peter's problem to say, okay, let's do a toy problem just to get the machinery working. And so people can get familiar with different packages.
One quick question before you go.
Yeah.
In this sort of mode that we've been having, you would take the votes, and so if when we had an equal number of yes and an equal number of no, you said that is a no, and otherwise
it depends on the voting rule.
Hmm?
It depends on the voting rule. I was operating with a 3/4 yes.
Okay, gotcha. Okay.
You don't have to. You could have a simple majority. I've even done events that we had 1/3 because the domain was judged to be very loosely connected, and we're working in a more hypothetical way, and we wanted to kind of consider all the possibilities. So we just took 1/3, and a third of the majority is typically what's used to keep an idea alive, not approve of it, but it's a cult. That's the 1/3 vote is a quorum. So it just depends on what your particular task is, what the domain is like.
Yes, okay, but I mean that's something that needs to be sort of established before one begins this. Is the voting rules? I think that's an interesting, requirement to be clear about.
Right. But you also can, if you have the voting record, it's something that you can relax to any voting rule afterward.
Okay.
Yeah.
Thanks,
Okay.
Kevin.
See you later.
Yep. All right. That was great. Very interesting. What would we like to talk about next?
Well, I think it's helpful to begin to do something like this because to me it makes it more real, and I have felt a little hampered perhaps by the previous discussions we've had when an actual example is not easily presented using the software. So to see that in Cognoscope, and then, as Kevin said, to perhaps do it in your software, Joe, and to help us sort of get into the comparisons or understand then you know, what is similar and what's different, that would be good. And the other thought that came to mind in looking at the map that was created there when, or the structure, maybe more accurate term, that was created for that toy problem, that behind that toy problem and that mapping is the mathematical or the structuring process, and the transparency of that is something that would be helpful to be able to explain to those that don't necessarily get into the programming side of it.
Yeah, that's really a good point, Peter. I think there's a fundamental aspect of what Mary and I are doing is we're exploring and documenting the isomorphism among prose, structured graphics, and mathematics. And so right now what we're doing is we're taking these prose natural language relationships and mapping them to the mathematics in detail. And Kevin and I were talking a little bit before the session started recording, where other people showed up, and basically next month what we're going to present is the clustering algorithm, or clustering function from the GMU ISM software. Now that is closed source. We've implemented an open source piece of software that reproduces that clustering function. And we plan on talking about that. So our first challenge in this case was to go through and to start to document all the different ways the natural language relationship clustering is used in structural modeling and ISM.
Can I ask you?
Sure, go ahead.
Does that and can you mention how do cycles relate to clusters?
Okay, excellent question, Janet. So the definitions for a cluster that we're working with really have two different kind of origins. And so in the natural language understanding relationship of a cluster in real world empirical space, right? We define a cluster as a group of objects that appear close together in some space, two-dimensional, three-dimensional, n-dimensional, whatever. So these objects that appear together in some space defined by some dimensions. And then the cycles, specifically in the structured graphics representation of the mathematics that associated with the natural language relationship, you have feedback. And so feedback in a graph, and that's what cycles, and that's kind of a comment that Kevin made there. So that one definition that we have is that, a cluster has feedback on the graph, and then, or a cluster is a group of objects that are appear close together in some dimension.
Interesting.
And so those are the things that will be the topic of next month's report. We're going through that pretty much in detail, but starting just with the software clustering function for Moorfield's closed source software. And then we'll talk about that and what it means, and what are the advantages and disadvantages. And so that's basically our approach, is that we're going to take specific natural language relationships, because we are using people to, as our sensors. These people are taking their opinion and making their judgments. So we want to make sure that we have a good chance of having a common understanding about what that natural language relationship is. And then once we have that, then we'll transfer it to the mathematics and see if we can get any inference out of it. So the idea of large-scale systems, very large scale, have a lot of objects. What we want to do is we want to optimize resource use or minimize resource use by using inference. And as we pointed out in the interconnection matrix, it appears that there are some multi-threaded types of natural language relationships that will not allow us to effectively use inference. Now you can map them. You can use those mathematical functions and you can map it onto the structure, but it might not, it might not be truly mathematically valid for specific types of natural language relationships. But then you need to make it. But if you have nothing, right? It's just like if you blue sky, you have no understanding at all. You have of a structure, and you want to use this natural language relationship that's multi-threaded. You also want to minimize the resources that you're going to expend. Let's say this is an exploratory activity. Then you need to make a decision. You say, oh, okay, I am going to use this natural language relationship. I am going to use this specific mathematical approach. I know it won't be repeatable. I know basically it's non-deterministic, but at least it'll give me something, right?
Right.
So that's kind of a risk management thing. And so that's kind of how we're going to hopefully, well, that's how we're going to start framing the discussion and saying we have some of these isomorphic relationships that are mathematically solid. We have other ones that we know are non-deterministic, and we're going to use those in certain cases where we have nothing else. And then there's a couple other gradations that we'll document later on.
Yes.
Does that answer your question?
I need to go too. Yeah, that is wonderful. All that sounds very good, very clear. And this is what Kevin did here is very helpful. Good in Peter's work. The issue of the lack of cycles is a huge insight that maybe really sort of it's a massive problem that Peter can mull over how he wants to approach that in the people who are working on the concept map there. But your treatment of cycles and clusters maybe would be very profound for helping them understand how clusters and cycles could be better.
Well, Novak, when he talked about his concept maps, said when you look at a novice concept map, it's asymmetric, no cycles. And you look at an expert's concept map, and there's many cycles.
Very interesting.
Yeah, so if you start looking at knowledge representation and the work that's been done there, especially with Novak's work, the idea that you have a hierarchical decomposed asymmetric connections indicates a novice is doing that.
Right. Very good. Okay.
Okay.
Glad I caught
Thank
that.
you.
Thanks. Bye-bye.
Bye.
That's a good concept to for me, well, to explore some more too, because I guess that was from Kevin's analysis of that concept map, which is actually for grades 9 through 12 and would be the culmination of a high school career, but the linearity of the way that the relations were constructed was a sort of an outcome of the process of how they were put together. And the lack of the cycle observation that he made, I mean, it may be there implicitly in other ways that's not explicit in the mapping of the concept, but it's certainly worth digging into. And I, to the other thing that would be very helpful, Joe, to learn about, would how with using either the Cognoscope or the GMU software or your software, enable us to produce those kind of concept maps for our own project on systems literacy and the concepts that would fall out of, say, Boundary, you know,
Yes, so in this specific case, we're talking about curriculum development. There's, and again, this is another point that Kevin and I had a discussion before we started recording the meeting, is there is an application structural type in the ISM documented literature that's called curriculum structure.
Yeah, yeah.
And so now I looked at that, and I've looked at it a number of different ways, okay? And sure that I clearly understand how that is developed using the software. Now, I think I can understand how you would develop it by hand, right? And do it that way, but it's not clear to me how you would use something like the GMU ISM software to develop a curriculum structure. So I'm, and that's why we're taking this approach where we're doing very fundamental pieces first, going to explore those in detail, and then work up to these more apparently complex type of natural language relationships. And we're in the process of trying to develop a standard framework for the analysis of these specific natural language relationships. So we can start getting an idea of what's important to the mathematics, what's important for the human understanding. So it's very it's well documented in certain cases, but to be honest with you, there are a number of documented mathematical relationships and natural language relationships that I'm just not quite sure how they work. And so I'm not focusing on those. I'm focusing on the ones that I believe I understand how they work.
Well, that's a way. That makes a lot of sense. That'll save you going insane, wouldn't it?
I thought it was quite convenient.
Keeps Mary happy too, I'm sure. So what would be helpful is any references to the curriculum structuring that you could give. That would be appreciated. And any thoughts on how we might use it in the development of a similar kind of structuring for systems literacy. Even just to take that one example of Boundary, which I think is a central or a key aspect of systems, and I think that's probably why Kevin picked it, is how would we start to build a curriculum to understand Boundary, for example?
Yeah, so I think it was in the one of the last 4 technical reports that we did. I think it was associated with the application structural types.
Okay.
When I looked at the Science of Generic Design, and I looked in the Handbook of Interactive Management, I think I just focused on those 2 documents. And the question I asked myself is, they've documented and presented case studies. And what I did was I looked at what was the attributes of the natural language structuring relationship that was used in the triggering question. And that was very simple. Is it a global attribute? Does it have a global attribute, or does it have a local attribute? And a very small percentage of those triggering questions had local attributes. There were some that did, but very small percentage. And the vast majority of those triggering questions appeared to have a global attribute to the natural language relationship. And so if I remember correctly, the universities and the people that went through and creating curriculum structure they did a series of events, and their first, and so they did, and each event had a different triggering question. And I believe the majority of those triggering questions were like prioritization, prioritizing goals, prioritizing different aspects of what the group was trying to do. And that is, so the prioritization piece and the ordering piece is definitely global, and it's a type of activity that's fairly straightforward that we can do with our software just straight up. But when it comes to the saying, well, then they do impacts or implements or impact or aggravates or the curriculum structure, that doesn't map directly to a software piece that we have. That basically, in my mind, looks like it's going to be a multi-threaded approach. And that's what we're working on now to actually complete that mapping. But I'll send you the I'll send it out to the list of pointers on the curriculum development and the literature.
Thank you very much.
You're welcome. Sounds like you have a what size group and what kind of distribution are you working with here on this systems literacy, ocean literacy activity?
Well, the ocean literacy is an evolving initiative and campaign that obviously started in the United States, but is now in the process of going worldwide. That was the impetus for me talking about systems literacy in Berlin in 2015, which has led to these discussions over the last couple of years. And there is no explicit relation or project that has people working on the ocean literacy to systems literacy connection, except for me to be using it as a reference point, illustrative of what is possible. We haven't got to the same level of detailed description of systems literacy that we have for ocean literacy, but that's really the nature of the project to do, that we need funding for. And we're looking for funding. And then the approaches to do that could follow some of the ways that we did it for ocean literacy, but given these discussions, it would be, I think, interesting to explore how structural modeling could help create something similar for systems. And then, of course, yes, to do as Kevin just initiated, is to look at how one informs the other. And indeed, that may be the way to actually evolve the systems literacy concepts and big ideas, is by looking at what has been created for ocean and earth science and atmosphere and energy, and perhaps biology and living systems, to inform the content of what could be considered systems literacy. I think that's certainly one approach that we've been discussing, and maybe using, whether it's your system or Cognoscope or the GMU system, whichever one is most appropriate, or all of them, to see what might come out, and how to do it would be, an interesting project to write up.
Yeah, okay, that is that gives me a little bit better idea. I have a tendency in my own mind to think about, when you say like ocean systems and atmospheric systems, global systems, economic systems, whatever, anything that has an adjective in front of systems, that is more, much more specific, and it has domain-specific interpretation, and semantics is definitely more specific than the realm of systems, right? So that systems is more general, and so that demarcation between what are the things that are in systems literacy should probably map to all those areas that you're talking about. So they're going to be a little more general. And one of the things I think that is interesting about that, and that we've been working on, is what are the general concepts that are applicable across all of these implementations. And so right now we're just working with very simple ideas of ordering, types of sequencing, clustering, and those, you would find examples of those, I think, in almost any type of science. What that means in a specific science is probably, it might mean something a little different in each specific science, but some fundamental level, that's all kind of the same thing. Of course, all finally backs up to mathematics, but it'll be. So I think Mary and I are working on something that's just we're trying to make a very clear distinction between the natural language relationship and the mathematical implementations, and what if there's any risks involved at all in the semantics of using one mathematical implementation over another.
Yeah, absolutely, and I'm quite, absolutely, I understand that. But I mean, when you look at the initial intent of the General Systems Research Society, now called the International Society for System Sciences, or for the, it was to look at these sort of isomorphic properties, or these shared properties or characteristics, and I think that this is just another part of that ongoing development.
Yeah, I agree. That's kind of the way I see it. I actually am struggling a little bit right now because most of the general properties I see, I'm trying to figure out what's the discriminator between what I'm calling a general system in mathematics, and what's the discriminator between what I'm calling a general system and a specific system, right? Semantically, and
right.
For the general systems to be different than mathematics, they have to have some informal content to them. They have to have some tinge of natural language relationship. They have to have some tinge of informality in the language, because if they don't, it's mathematics, right? And then the semantics in the application space, then that needs to be different and more specific than the general systems piece. And actually, that's one of the kind of underlying reasons to do this mapping from the prose to the math to the structured graphics.
Absolutely, yeah, it's good.
Okay, well, I think we're getting close to the end here. Is there any final comments?
No, I just, as ever, I think this was another good couple of steps forward in understanding application and opening up, a way to demonstrate the rigor of the, as you say, the ordering and the structuring, which helps to really increase our knowledge about the world, which is the ultimate purpose of all of this, I imagine.
Hopefully. Okay, well, we'll try to go a few steps further in a couple of weeks when we start our January conference. Let's see, what day is that going to be specifically?
January 6th.
January 6th, Saturday. Okay. We'll,
very good. Thank you very much.
Fun.
Take care.
Thank you. Bye-bye.
Merry Christmas.
Yes, Merry Christmas. Happy New Year.